Math lesson number 18. Rational algebraic expressions. When the numerator and the denominator of a fraction are both polynomials and the denominator is not equal to 0, then the fraction is called rational algebraic expression. Examples: 2 over y. So 2 is a polynomial, y is a polynomial. Therefore, this is a rational algebraic expression. X plus 1 over x minus 2, both are polynomials, as well as x squared minus 3x plus 2 over x squared minus 1. So these are examples of rational algebraic expression. In general, rational algebraic expressions can be written as a over b, where a and b are both polynomials and b is not equal to 0. In 2 over y, y must not be equal to 0, because if y is 0, then 2 over y is undefined, which must not be. In x plus 1 over x minus 2, x must not be equal to 2, because if x is 2, as you can see, 2 minus 2, that will be 0. So denominator must not be equal to 0, because this will be turned into an undefined expression. Next, x squared minus 3x plus 2, x must not be equal to 1 or negative 1. So as you can see, if you're going to substitute 1 here in the denominator, x squared, that's 1 squared, minus 1 is 0, so which must not be. Negative 1 quantity squared, minus 1 is 0, which must not be also. So as these values make the rational expressions undefined, so such values are restrictions on the variable. So take note of the restrictions. Those are the values that make the expression undefined, or that make the expressions undefined. Let's have the first example. Find the value of the variable x in x plus 2 over x minus 4 that makes the expression undefined. So a rational expression is undefined, take note, when the denominator is equal to 0. Thus, to find the value of x that makes the expression undefined, set the denominator x minus 4, that's the denominator x minus 4, to 0. Then solve for x. So this is the illustration. X minus 4 is equal to 0. X is equal to 4. Now when 4 is substituted to x in the expression, x plus 2 over x minus 4, the denominator becomes 0, making the expression undefined. Therefore, the answer is 4 in our first example. What value of x makes the expression undefined? So x is equal to 4. Of the variable in 3 over x squared minus 5x plus 4 that make the expression undefined. Why I ask for the values, not value? Because as you can see, in the denominator, this is a quadratic expression. So if you're going to factor that, there are 2 factors. So later in our solution. So let's have, first we factor the denominator, x squared minus 5x plus 4 is equal to x minus 4 times x minus 1. So this is factoring general trinomial. So factors of x squared, x times x. Factors of 4, you can have 4 and 1, and then because this is negative, so you have negative and negative here. So let's check the middle term. negative 4 times x is negative 4x. X times negative 1 is negative x. Negative 4x minus x is negative 5x. So this is the factored form. Now, when x is 4, the denominator becomes 0. That's correct, because if you're going to substitute 4 here, 4 minus 4, that will be 0. And 0 times this is 0. Therefore, this denominator will become 0. So, one restriction is 4. The other one is when x is 1. So, the same, the denominator becomes 0 when you're going to substitute 1 for x. So, that's 1 minus 1, 0. 0 times this is 0. The denominator becomes 0. Therefore, the expression is undefined when x is equal to 4 or x is equal to 1. Next, a rational expression is said to be in simplest form when the numerator and denominator have no common factors other than 1. Let's have example. Simplify and state the restrictions on the variable. So we have 5x squared divided by 10x cubed. First, we simplify the fraction using the law of exponent. Okay, so we have first 5 divided by 10, that is 1 over 2. We're going to simplify that, and then using laws of exponent, we have x squared divided by x cubed, that is quotient rule. So 2 minus 3 is negative 1. Again, 2 minus 3, so you need to subtract the exponent, that's negative 1. Since the exponent is negative 1, you will have to change that to a positive exponent by transferring the x to the denominator. So this one is the result. So the result is 1 over x. So again, x raised to negative 1 is equal to 1 over x. So multiplying 1 over 2 times 1 over x is 1 over 2x. So this is the simplified form of this. Now let's have the restriction. Since the denominator is 2x, what value of x makes 2x 0? Of course, x must be 0 in order for this 2x to become 0. Okay, now our restriction here is when x is 0. So in order for this not to be undefined, x must not be 0. Next example, simplify and state the restrictions on the variable. 2x plus 6 divided by x squared plus 5x plus 6. So 2x plus 6 has a common monomial factor of 2. Extracting this 2, the remaining factor is x plus 3. Next, we have the denominator x squared plus 5x plus 6. This is factoring general trinomial. So factors of x squared are x and x. Factors of 6, that will make the middle term correct, which is 5x. So we have 2 and 3. So factored form of this is x plus 2 times x plus 3. Now as you can see, in the numerator you have x plus 3, in the denominator you have x plus 3. So cancelled, cancelled. The remaining now is 2 over x plus 2. So that's the simplified form. Now, going back to this one, let's take a look at the denominator. If x plus 2 is 0, then the whole thing will become undefined. Because if this is 0, 0 times this is 0. Therefore, the denominator is 0, which must not be. Therefore, x plus 2 must not be 0. And on the other side, x plus 3 must not be 0 also. So x must not be equal to negative 2. If you're going to transfer that to the other side, it will become negative 2. 3 will be transferred to the other side, it will become negative 3. So you need to isolate x, and here x also. So the result, x must not be negative 2, and x must not be negative 3 also. So those are the restrictions for this expression. The last example. Simplify and state the restrictions on the variable 2x squared plus 9x minus 5 divided by 3x squared plus 13x minus 10. So first, let's write the example, that one. Now, this numerator is a general trinomial in which we can be factored that into x plus 5 times 2x minus 1, wherein 2x squared as the factors of x and 2x, negative 5, we have 5 and negative 1. And then 3x squared plus 13x minus 10 as the factored form of x plus 5 and 3x minus 2. Same reason, factors of 3x squared are x and 3x. Negative 10 are 5 and negative 2. So this is a perfect combination to get 13x, and this one for 9x. As you can see, in the numerator you have x plus 5, so we can cancel that. X plus 5 also in the denominator. Now, the remaining factors are 2x minus 1 and 3x minus 2. So the simplified form is 2x minus 1 over 3x minus 2. Now let's go back to this one to find the restrictions. So as you can see, this is x plus 5. So we let this be equal to 0 such that x must not be equal to negative 5. So we must restrict x to get negative 5, because if x is negative 5, this will be 0, and if this will be 0, the whole denominator will be 0. Another is 3x minus 2. So 3x minus 2 must not be equal to 0. And then we transfer negative 2 to the other side, so that will be 2, and then we divide by 3, so it will be 2/3. So x must not be 2/3 also. If x is 2/3, 3x minus 2 will be 0. And if that is so, this whole denominator will be 0. So the restrictions are x must not be negative 5 and x must not be 2/3.